Okay, we're going to do solving applications using systems of equations. And you have been doing equations like x plus y equals 7 and x minus y equals 3, and then you've been canceling things out and so forth. And so now, instead of you just solving the equation, you're going to have a problem, a real life application to help you find these. These are more difficult, but they're realistic. You're not going to walk around the grocery store and find something that says x plus y equals 7 and have to do something to find a price. You're actually going to have to say, well, this tomato is twice as much as that cucumber and how much and so forth to figure out the prices of things.
Right.
So it's a good skill for you to know the word problems. They're just going to be a little more difficult because they take more brain power. Okay. We're going to do this problem in two ways. We're going to do this in the old way with just using an x and not x's and y's, and then show you how to take that same problem and do it like a systems of equations like we see here. Okay. So first of all, we're going to do Sandy's garden is 15 feet longer than it is wide. The perimeter is 102 feet. What are the dimensions of the garden? And so we have a garden, and we assume that it's a rectangle. Okay. And we have a width, and we have a length. Okay. And it says that if this is W, then this is going to be W plus 15. Does that make sense? Mm-hmm. We could have used the letter X also. So we could have said, if the width is X, then this is X plus 15. Does that make sense?
Okay.
So that would make this one X plus 15.
And then equals 22?
X. Mm-hmm. Now the perimeter. How do I find perimeter?
Oh man, I can't remember the equation for it.
What is perimeter?
The outside.
Yes, so I'm going to take this x, and this is also x. So I'll have x plus x, or I'll have two x's. Does that make sense? Mm-hmm. And I'm going to add this here, and there's two of them. So I'm going to have 2x plus 15 equals, and it says 102. Right now we only have one variable. Okay,
right.
No x's, only x's, not y's. This is going to become 2x and 30. You with me so far?
Mm-hmm.
We're going to bring that together, and that's going to be
30 equals 102, and then 102 minus 30 should be 72.
Okay, so 4x equals 72. Does x go into 4?
Wait, 72 divided by 4. 18.
Okay, so x equals 18. So we're trying to find the dimensions of this thing. So if I change colors just so we can see this better, we know that this is 18, but I need to find that.
18 plus
yes,
15.
Very good. I plug that 18 right there. 18 plus 15.
Thanks. Should be 37, right?
I think it's going to be 33.
Oh, yeah.
Okay, so it's going to be 33. So it's going to be 18 feet by 33 feet. And so that's only one variable, very similar to what you've been doing, which we have x and x plus 15 with web width.
Yeah, that wasn't hard.
So let's do another one. Well, this time we're going to be the same problem, Sandy, but we're going to do this with an x and a y. Okay?
Okay.
So we know, or we can do it with a w and an L, because we have the length and the width, okay? So if we know that we have a perimeter, and if I called this one x and this one y, my perimeter would be 2x plus 2y equals 102. Does that make sense? Mm-hmm. Okay. And they said that this is x is 15 more than the width. Mm-hmm. They said that the longest one, and there's my is with equals, is 15 more. Does that make sense? Mm-hmm. Okay. There's a couple ways we can do this. Now that we've solved for y, we could use the substitution method and substitute it right in, but you tend to like the other method. You tend to like it when we have the cross out way. Yeah. So I'm going to move the x over by subtracting. Okay? So I'll have negative x plus y equals 15. Does that make sense? Mm-hmm. So what I'm going to do is I'm going to bring this one, this first top equation. I can't. I'm going to have to make this smaller. I don't have enough room. Actually, wait. Cancel. I can add another piece of paper, I think. I just move this one. Just okay, I'm just going to scoot it over a little so that I can move them up and have some room to do this problem here. Okay, so what I'm going to do is I'm going to multiply this one by 2 so it'll cancel out, so that my x's will cancel out. So I'll have negative 2x plus 2y equals 30. I'm going to rewrite the 2x plus 2y equals 102. Do you understand what I'm doing?
Mm-hmm. So then you'll cancel out. It'll be
Yes.
4y equals 132. And then divide by 4, which should be like 80 or something like that.
Okay.
Wait.
What'd you
Oh, 33.
do? Okay.
Why did I think 80? I don't even know.
We have 33, so we know that this is 33. Okay, so we have this here. And so I plug that in and I say 33 equals x plus 15. So I'm going to subtract 15. And that should be 18. I think that's what we got over here. We got 18 and 33, right?
Yeah.
Okay, so we did that 2 different ways. We did one with just one variable and then one with 2.
Right.
Okay, so let's do another one. This time we're going to do them all with 2 variables. It says the sum of 2 numbers is 53. I'm going to stop there.
Okay.
I have 2 numbers. I have an x and a y. And what does the word sum mean?
Add.
I'm going to add. And it's going to equal 53. You with me so far?
Mm-hmm.
Okay. So then it says that their difference is 11. What does difference mean?
Subtract.
Right, so I'm going to go x minus y. It says the difference, I cut it off, is 11. It wants to know what those two numbers are. The nice thing about this is it's already set up for us, right?
Yes.
So
Okay.
2x equals 64.
4, and then divide by 2.
Uh-huh.
Should be, I don't know, 32.
Okay. All right. Now, that's just what x is. So how do I find what y is?
Then you plug the 32 in
Yes.
for x. So then 32 plus y equals 53. Minus 32 equals 21.
Okay, so there's my 2 numbers. Okay.
This isn't as bad
That's
as
not
I
as
thought
bad.
it was going to be.
Good. Let's do another one. We have Rhonda spent $11.18 on 30 postage stamps that cost 47 cents for letters and 31 cents for postcards. How many of each did she purchase? And so, what kind of things did she purchase?
Okay, she purchased stamps and letters and postcards.
So we got letters and postcards. So when I do L, I'm going to do this kind of an L, okay? And we got letters and postcards. How many total things do we have?
2.
How many total postage stamps did she get?
Oh, 30.
30. So we have letters plus postcards is going to be 30. Does that make sense? Mm-hmm. Okay. And we've done something like this before. How much does it cost for each letter?
Oh, yeah. 12.18.
That's total. That's our $12.18.
Okay, so for the letters, it's 47 cents.
Yeah, so we're going to have to do 0.47 for letters plus
0.31 for
0.31 for postcards. We've done something like this before a while ago where we had to do the values in front. Right. And now we have them on top of each other. I am going to take this decimal out by just doing 47L and 31P and 1,218. Okay, so we're going to have to multiply either the L's by 37, everything by 37, or everything by 31. What do you want to do?
Okay. Yeah, sorry. I'm like, okay.
That's okay.
The L's.
You want to do the L's, and so you want to do the 47? We'll do negative 47. So we're going to need a calculator. So I'm going to have negative 47L and negative 47P, but I don't know what 30 times negative 47 is.
Negative 1,410.
Negative 1,410. So then, when I cancel that,
equals negative 192.
Negative 192. That's okay.
Sorry.
That's all right. And 31 minus 47
is 16. Negative 16.
All right. Divide by 16.
12.
Wow. So P is 12. So they did 12 postcards. How do we figure out how many letters?
Oh yeah, we're gonna plug the P in for the P.
Yes, I would do it up here. We know there's a total of 30. So we're going to plug in it right there. So we'd have L plus 12 equals 30, right?
And then 30 minus 12.
Yes.
Which would be 28, right? 18. 30 minus 12. 18.
So L is going to equal
18.
18. And you'll want to put the units out there after you're done.
Okay.
All right, here we go. Jason took 2 days. A 2-day, 1,140-mile trip from Boston to St. Louis. If he drove 10 miles more on the second day than on the first, how many did he drive each day? Okay, so like we did last time, we need to find something plus something equals the total.
1 day plus 1 day.
So how many he did? Like we could call it first day and then the next day, because I don't want to use an S for second. So first and next.
Yeah.
And so we're trying to find how many did he drive each day? How many miles?
So then you do X and X plus 10. Because we don't know how many miles he drove the first day, but he drove 10 more the next day. So you do X and X plus 10 equals.
Oh, okay, so you want to do it that way. So we want to do X and X plus 10. Yes?
And then equals 1,140.
So we add them together?
Mm-hmm.
So it says, so we add that together, and that equals, all right, so then we're going to just do the method with just using one variable, okay? And so we're going to have 2x plus 10.
And then you're going to subtract 10 from 1,140, and it'll be 1,130 equals 2x. And then divide by 2, which will become 556. No, 565. My bad. 565. And then you're going to add 10.
Yes, because we're going to have to add 10 for that one. So our other one will be 575, and that is miles. Okay?
Awesome.
Last problem. Eric split $8,000 and invested into 2 accounts. One earning 3.5% and the other earning 5%. If his total interest earned was $332.50, how much did he invest? Okay.
Okay, so you're going to have the first account and the second account.
Yeah, so we'll have an X and Y.
Mm-hmm.
Okay. So we have a first account and a second account, and that totaled $8,000.
Mm-hmm. And then you have the 3.5 in one and the 5 in the other.
And the other, and this is Y, and that's going to be 332.5.
Okay, and then
Just 1 second. We're going to actually, since this was in percent, since I didn't write it over 2 places, I can't. I have to make this be no decimal and a 0. So it'll be 32,250. Does that make sense to you?
yeah.
Okay. So we either have to put this in 0.035 or we have to make that in big numbers. Okay? All right. We need
Then you're going to multiply by 5 up here.
5. Okay. Negative 5.
Yeah.
So we'll have negative 5x
Plus,
minus 5y.
Right, and
Okay.
then is, oh yeah, and it's going to be negative.
Yes. So then can you take positive 32,250 and add it to the negative 40,000?
And add it.
Mm-hmm.
72,250. And then divide by negative 1.5 is negative 48,100.
Yeah, this was actually a negative, so it should be positive now. X equals how much?
It just went away.
Oh, I'm sorry.
Negative, it's not your fault. $48,166.66667.
Did I do that right? Is 3.5 minus 5 1.5?
Yeah.
Okay, so 48,000.
Oh,
I'm sorry.
no, you're good. Divide by negative 1.5 is 48,000.
166.66. That'll be dollars. How do I find the other one?
Then you're going to put that in for X. And then you're going to subtract it from 8,000.
Yes.
So 8,000 minus 48, 166.66 equals negative 40,166.66.
Yes. Can be negative.
It's negative, yeah. Oh, can it be negative?
It can't. Oh, we did something wrong.
Oh boy.
Okay, this is not logical to have all this negative, so we're going to have to start back up here. Okay, so this right here, when we put it in our calculator, we should have got something different. We should have gotten 7,750 divided by 1.5. That's better. We're going to get negative, by the way. 5,166.66. That's more likely. We can't have more than 8,000 when we're done. And so the other one, we're going to have to subtract from 8,000. And then, oh, great. So let's do that again. 8,000 minus 5166.66. We'll have $2,833.34 in both of those accounts.
Okay, that's not too bad.
Yeah.
That one was
A little harder because all those big numbers. Yeah.
Okay.
So you're going to have to try to figure out, since we're doing money, we have a total money and a total money, and we're splitting it. So that we're always going to have to find that big total. What are we splitting? We're always splitting something. Especially on this one, we had two different kind of postage stamps, and we had a total amount of postage stamps.
Right.
And so when we had back here, we had a total, and we had a difference in this one. That was nice. And this one, we had a total number of, the whole thing was 15 feet long, and so this one actually was slightly different. We didn't have a total because we put it in the perimeter, and it said one was bigger than the other.
Right.
Okay. All right. A lot of those we're going to have a total, and we're going to have something that totals up to be at like the 8,000. Okay?
Okay.
So just keep trying this. These are a little harder. Lots harder. Okay.